Hey everyone, welcome back to update 5. This week we were able to manage to implement a lot of the things we wanted to last week. This will also be the last update before our Midstone showcase tomorrow, but we're hoping that we could release more updates afterwards on the game. So what we added in general was a main menu, our title screen. We completed level 2. We added projectile enemies. Trying to think of what else we implemented. Let me just look in here. Oh yeah, we completed the functionality of the gun runner power up. And then we added a puzzle to level 2. So I'm just gonna skim through the title screen. It's not really that complicated to explain or expand upon, so I'll just click play. Takes us to Grandpa's house. Already showed this in the previous update. So we go back here, we go to the main map, and then we proceed to go into level 1 because that's where the projectile enemies are. So originally, these enemies here were not flying enemies and they did not shoot projectiles. Oh, there you go, you already attacked me. But we kind of changed up how they were compared to the normal slimes. Now they're actually flying, they're throwing some ground attacks. No projectile yet. It's completely random. This enemy has 3 different attacks. It could throw a regular projectile like that one, which you can't really parry. It could throw a blue projectile, which you can parry, and it'll damage it. There you go. And then it'll do a ground attack, which you saw previously. And these are all completely random. Oh, there you go. Oh, I don't even know what happened there. But yeah, that's for the projectile enemies. And then we added a puzzle to level 2. Let me load that up. Okay. Go to my player. For the sake of this video, I'll probably just move the player all the way to where the puzzle is, because this is level 2 is a pretty long level. I'll probably move him right about here. Okay, there you go. Not in the ceiling. There you go. Okay, so the player gets to this point of the game and then they're kind of hit with this here. So what we added was the actual clues to the puzzle, which Crescent finally comes in use for. So you use Crescent light, and then you move Crescent around, but then you notice you go down here and there's a color combination. So these are actually clues to the puzzle at the end of level 2. So what this is trying to say is the color combination is actually not just green, red, and blue, but rather it's reversed. So it would be blue, red, and green. So once we actually get to the color, the place to solve the puzzle, then that's where we'd have to input that color combination. I actually just forgot it. Let me just see what that was again. Okay. So blue, red, green. Okay. Then we just make it across this little platforming section we added with like conveyor belts. Alex implemented the conveyor belt, so he might speak about that in one of his updates. So yeah, I just make it up here. I believe there's a couple of enemies here. Yeah, Panther. Oh yeah, that was another thing we added was enemy health drops. I guess you guys just saw that right now. Or maybe there was an enemy that dropped it in level 1 and I didn't notice. yeah, there's like a little note here that gives you some hints as to where those clues were. So we're looking at blue, was it green, and then red. Oh, maybe not. Maybe it was blue, red, green. Yeah, there you go. And then boom. Once you actually, the player jumps on these buttons, and the animation plays, and it shows your input on the screen over here. So if you get the correct color combination, you have the ability to solve the puzzle and open this gate here. So once you actually complete that, boom, credits roll in, because we haven't made a level 3 yet. So yeah, credits roll in, thanks you for playing the game, and then returns you back to the main menu, where you're able to, I guess, start from the beginning. So I guess to start off, we'll talk about the puzzle itself. Okay. So for the puzzle, we had these kind of we added this lighting functionality, like I think like update 3, and then it basically uses shaders to darken the map. And down here we basically took just like a few circles, I believe. What was it? I believe it was under clues, puzzle, yeah, clues, and then 3 colors here. And then we added this custom plugin that offers this light 2D script, which just applies some shaders to it to darken it and blend everything together. So we put this light 2D thing on here, and then we enable alpha blend, which essentially blends with the whole map itself, and it kind of makes it a little bit darker as well. Like it darkens it, because here you can kind of see the reverse button, and then like a couple of these as well, without it turned on. So we turn it on to make a smooth blend, and so the player is not so the player is kind of forced to use Crescent, and is not just gonna look down there and be like, oh, there's a color combination, I don't need to use Crescent, let me just go up now. So we kind of force the player in a way to use Crescent, just as good practice, I guess. And then these buttons, again, once the player hits them, it plays an animation, and then the script decides what input the player, like what button the player pressed or stepped on, and then it'll take that input and translate it to the screen. So how we do that was we made a button script called button press. Let me just load that up. So here's the animator. This is how the buttons actually animate. We take the animator component, and then we initialize a variable called anim. We then get that. We then I believe retrieve the animator component in anim. So anim equals get component animator. So we're actually able to use the animator and animate the buttons. But besides that, we have string color, which is I believe this determines what color you pressed, I believe. And then guess array is essentially an array of strings that takes in information based off what button you pressed. I believe color is just a default variable. So if game object is a red button, then set color to color.red. If button is green, then set color to color.green, and then same for blue. And then we used, so in our update, we check if the guess array is greater than 0 and guess array, the first answer for guess array doesn't equal nil, so there's actually like an answer inputted for guess array. So like if we had an array of 3 strings, like let's say string 0, string 1, and then string 2, so it's essentially checking if string 1 has anything in it, and if it doesn't, it also checks if it has one for the first one, and then essentially the second one, and then the third one, because arrays in C# and C++ start at 0. So that would be your first number. It would start at 0. So we check if none of these equal null, so if they all have answers, then we start a coroutine called reset colors, which just resets the screen in general and resets the guess array so the player can guess again if they got it wrong. So then on collision is essentially where the player steps on the button, so it checks if the collision.gameObject.tag is equal to a player. So that's essentially if where's the player? Down here. I guess he's all the way back here again. So if GameObject, or if collision.gameObject.tag, which is right here, is equal to player, which it is, then it would calculate a height check. So this would determine so this height check is just to determine if the player is actually above the button, because the way if we just had this collision like this without a height check, the player can just run by the button and it would activate it. They wouldn't even have to jump on the button. So if that height check wasn't in place, then the player just runs by the button and activates it. So this makes it where it could actually detect if the player is jumping on the button. And what it is, it's just the player's position along the y-axis subtracted by the button's y-axis. And then it checks if the height check's greater than 1.25, which is kind of like an arbitrary, well, not really arbitrary, but just like a number that is known to be above the button. We could have used 1 as well, that would have worked. But we kind of went through like the debugging stage, and we decided maybe like 1.2, 1.3 was around a good number. So then we set a boolean value to still on button to equal true, and then this determines if the player is still on the button. And then we play the button animation, and then we start a coroutine called button press coroutine. And what this does is it first waits 0.45 seconds, and then we set the still on button, so it checks if still on button is equal to true, and if so, it checks right after that if the guess array, if the first string in the guess array is equal to null, then set an answer and change the circle 1 here. So circle 1.game component.get component sprite renderer.color. All this is just the first circle on the screen here. So we're just changing color 1's color, and here I named it circle 1. Should probably do the same here. And then else if color is not equal to guess array, so the first guess and guess array, and the first guess is not equal to null, and the second answer is equal to null, then set an answer for the second string there, which is equal to color. Color is just basically dependent on the actual button. So like if the button was red, then it would color it red. If it was green, it would be green. If it was blue, it would be blue. And then we do the same for here. For the third answer, we check if the first string in the array is not equal to null, and then we check if the color is not equal to the second answer, and then we check if the second answer is not equal to null, and then we check if the last and final answer is equal to null, and if it's equal to nothing, which is another word for null. So null no, nil, all those just mean 0 or nothing. And then so after we detect that the last and final string in the array is equal to null, we set it to its color that the player pressed on, depending on what button they pressed on. And then we set circle 3 to whatever color that the player jumped on. Otherwise, if there's an answer for all 3, then just reset the color again. Reset all the colors and then reset the guess array so the player can guess again. As you see here, for int I equals 0 and I is less than 3, add to I, and while you're adding to I, set guess array and all of its component to null. There's definitely other ways you can go about it. This is just one of those easier routes, I guess. You could also do it manually, but that could become a little tedious. I'm sure there's a whole lot of different methods you could use with arrays that could clear it out. I'm pretty sure there's one for a list, which is what we used, I believe. We used arrays and lists, which are kind of the same, pretty much the same, but just with different different, I guess, functionalities in a way, because you can do stuff. You can do things with lists that you can't do with arrays. To some extent, I guess. So if you're confused about this color thing, this just checks if, so for in this instance, so when we're setting let's say color 2, we just check that it's not equal to the previous color. So all the colors they're inputting won't be the same, or won't be the same color in a row. So if let's say you got red, or let's say the puzzle randomizer threw in red, it wouldn't work like that. It wouldn't allow you to choose red twice. Here, I could try showing you guys that. That's all it does. It just, this color not equal to portion, it just checks if this current or the previous answer you just put in. So let's say guess array, so the second guess array 1, so the second string in the array. So it checks if that is if this new color that the player clicked on is not equal to that previous answer, and if it's not, then they're allowed to set the guess array 2, which is the final answer. So it's kind of just a way to not have the player just press red 3 times, which is kind of boring. So we kind of switched it up and made it fresh, I guess, so you're not always just pressing red or blue or green like twice in a row. So let me just try showing you guys that. Move the player. It's another long walk. Okay. Alright, so let me show you that. Okay, so we go on the red button, we go on it again, it won't let us press it. And so that's basically where this comes in. It checks if the previous array was, if the previous answer in the array was equal to the, or if the current answer in the array was equal to the previous answer, I guess. It's kind of hard to explain, it's like blowing my mind at the same time. So yeah, so if we try switching to green and then picking green again, it won't let us pick green because we already picked green here, so it won't let us pick green again. It'll definitely let you pick the same color twice, but not in the same order, like not in a row. So I could pick red again right now, but of course it's incorrect. I kind of wish there was an easier way to explain this. There probably is, I'm just bad at explaining it. So yeah, that just checks if the current color is not equal to the last answer I tried putting in, and if it's not, then you can actually input something. See, I can't pick red anymore, but I can go to green, I can go to blue. Okay. So once all that happens, we have another script which checks if the answers are actually correct and randomizes the answers. I believe it's under, trying to exactly remember. I think it's this right here. We called it door color puzzle, and we have, I guess, 2 arrays. Off the bat, we have one called puzzle color answers. So this holds all the answers that the player has guessed, or these are all the answers, and then we use the guess array to compare to the answers. We have puzzle guess, which is what the player's guess is. We take whatever the player guessed in a button press, and we set puzzle guess to that. I believe we did that somewhere here. Yeah, right here. So guess array in the button press is actually just equal to the, so we get the gate component, and then we get the door color puzzle, and which is in here, and then we make it set to whatever the puzzle guess is. So it's essentially the same array we're working with. That's sending data to this script here, so it checks if the guessed array is equal to the puzzle, to the actual answer. We initialize some UI that's shown to tell the player whether or not the code's incorrect or not. We have the game object door, which is the gate that opens up if you get the answer right. And then we have a game object, and then circle clue. This is an object of game an array of game objects. And what these circle clues are just the previous clues I talked about, which is color 1, color 2, color 3, all under clues. So I initialize that, and then we have the door animator, which allows the door to slide open. Info text, we set the so here we actually create the array. So circle clue is equal to a new game objects with 3 different game objects within that array. And then we use game object .find, which is a little bit frowned upon apparently, using game object .find. I believe the recommended method is like, I believe get component or something, or find object with component. And then in start we also create an array of 3 strings for puzzle color answers. We randomize the colors, so we call a function called randomize colors, and all this does is it takes the current list of colors and it randomizes it, and that's what the player has to guess, I guess. That's what the player has to actually figure out. So let's say the original answer was red, green, blue, so RGB. So what this would do is it would make it backwards, so it would be BGR essentially. But the correct, so like it would show it as BGR in color format, but since there's a little clue here saying that it's reversed, the player would have to input it into the screen over there as RGB, which is red, green, blue. And then we also create an array for the puzzle guess, 3 strings. We set them to a null, just good practice to initialize them and set a value to them. Alright, so this is where we use a list. We have colors in list, which is a list with all the colors in it. And then there's a list for all the reversed answers. So it takes the colors in the list and it reverses it. So in the list, and the colors in the list, we add color.red, color.green, color.blue. We could have definitely used just blue, red, green, blue, but the way I went about this was I thought it would be so easy that I could just set the game object's color to a static to the static colors that they offer that Unity offers through a string, but that was a hassle, so I guess we just left it the same. And then we created a for loop. So while I is equal to 0 and I is less than the puzzle color's answer, which is 3, so this for loop will go about 3 runs, 3 times, and then it determines the current selection, which is, I believe this is current selection. I'm trying to think what this was again. Current selection. 0 to colors and list dot count. So this picks so what this does is it picks a random color in the list, and then it sets the puzzle's answer to whatever the current selection picked out, and then it converts it into a string, and then we remove that answer to avoid duplicates. So let's say current selection picked out like 1, 2, 3 because there's 3 strings in the array. It would randomly pick one from 0 to how many colors are in the list. Now that I think about it, oh yeah, 0 works because arrays start from 0. I'm more used to the Lua approach where arrays start from 1, but I'm sort of getting used to the 0 now. It probably makes a lot more sense to start from 0. So there you go. So let's say we had an array of 3 strings, 1, 2, and 3. So what remove at does is this is what I was basically talking about, that a list kind of offers more efficient or easier approaches to doing things than an array does. So it allows us to actually remove stuff from the list, or the list in this case. So let's say what this prevents from doing is picking out the same answers. So let's say we got like 3, 3, 3. Well, what this does is once you pick out 3, there is no more 3 because it removes it. So it either has to pick 2 or 1. And if it picks 2, it can't pick 2 or 3 because they're both removed from the colors in the list. And that makes it only one more color in the list, therefore it being 1. So all these colors are unique. And then this also comes into play without being able to select or press the same color in the row. It all works out in a way with how this was scripted. It's also just a lot better because having to press red 3 times or blue 3 times isn't a whole lot of fun. Okay. And then once we do all that, once we set all the puzzle answers, we then reverse those answers in the reversed answers list. And this is also another easy functionality that a list offers that you can't really get out of an array, or it's a little bit harder to do with an array. So we just take the puzzle color answer and then we do dot reverse and then parentheses, and then we convert it to a list, because I believe before if you just did reverse, it wouldn't really convert it into a list. So you kind of have to manually convert it to a list at the same time. And then as we do that, we created a for loop going from 3 to 0, which essentially just sets these 3 circles here to their colors in reversed, I guess. And then to detect that the guessed array is equal to the puzzle answer, we use if puzzle guess dot sequence equals the puzzle color answers, then the player has solved the puzzle, and then it'll open the door and do all that stuff. Otherwise, if they don't equal to any of the answers, then code is incorrect, so therefore try again. Okay. So that's pretty much it for the puzzle. The enemies were pretty simple. With the enemies, the projectile enemies, we just took the ground enemy functionality and we changed a couple of things. If I could find it here. Don't know if I could find it. Right here. So under a public void called update projectile enemy script. So again, this is inherited from we have a script called the flying green slime, which is basically the slime that was in the air, and it inherits from the enemy script. All of the enemies do, so we just made a public void for it. So first it checks if there's even a player. If there's not, then set the player. Otherwise, we check for the distance, check for the height. Similar to the previous enemy AI video, it's literally all the same still in terms of distance calculation, height. I'm probably not going to get into details about it now because I already did so in the previous videos. So you can probably check those out. I don't know why I said again like that. Like I was really angry. Alright, so it checks. So if there's it checks, for some reason it checks if there's no player again. I believe I don't really need that. That could probably be removed in the future. But otherwise, if there's no player, it just tells us that there's no player to follow. Otherwise, set the enemy's position to the player. So set the enemy's position, which is GameObject.transform, to a new vector 3, which follows the player's position along the x-axis, but then also has a random position of its own. So we created a variable called projectile enemy random position, and that's just a variable that's constantly changing in a coroutine or a loop, if you want to think about it that way. And this variable is constantly changing. So as you saw, I don't know if you saw in the beginning of the video, but the enemy was constantly moving. So that's what that was doing there. And then we take the initial position that the player was at, and then we add 3.5 to it, which allows it to fly in the air as it does. And then to make it look like it's bobbing up and down, kind of like Crescent, we added the mathf.pingpong as well. Such a weird naming convention, but you know, it makes sense, but it's just weird, I guess. Player.transform.z, I guess, is standard. This could have probably been done with a vector 2, now that I think about it, unless there's no vector 2.move towards. Oh, maybe there is. No, just in case, I don't want to really break anything, so we're just gonna leave it the same. And then we times it by speed and then delta time. We set the animation to true. This is the same old height stuff in the previous updates that I talked about. And then this is a debounce to check if the player, if the enemy can change position, because you don't want it constantly changing position. Otherwise, the player will literally have no time to attack or try to counter anything. And then it starts a coroutine called change projectile enemy position, which has a wait time of 3.5, so it's not constantly changing position. And that's where the projectile's enemy random position is set as well, from -15, so on the left side here, to 15 on the right side here of the player. And then we have something similar for the attacking. So this decides, so this variable here, which is a float called projectile enemy attack decider, is just a variable equal to random.range, so a number randomized between the numbers 0 and 100. And what we did with that was, if the float, I believe we had if statements here. So if the projectile enemy decider was less or equal to 30, then let the projectile enemy ground attack the player. And what the ground attack does is pretty simple. It just follows the player. It stops everything it's doing and it swoops down to attack the player. If I could even find it. Right here. I think it's this. No, that's an attack animation. Trying to find it. Oh, right here. So it just sets the enemy's position to wherever the player is. And then we start a coroutine called stop ground attack. Believe. And then this just allows the player to go back up in the air. We just reset a bunch of Boolean variables. And then doing that, since it's in the, I believe, update method for the projectile enemy, it'll reset the enemy back into the air where it originally was. And then from there, it'll just constantly change positions randomly as well. So it does the ground attack if the decider is less than or equal to 30. Otherwise, if it's greater than 30 but less than 65, do a normal projectile attack, which just essentially is, again, a debounce, and then we just instantiate a regular projectile. So this is a game object prefab that we have in one of our folders called projectile, and this is what it looks like in the bottom right. And then we have one called parry projectile, and then that one gets instantiated when the projectile enemy decider is greater than 65, and then we call the parry projectile attack function there. So there is that, and then there's the, what else? Before I forget, the enemy health dropper. That's what it was. I believe that was in here as well. Right here. So the enemy health dropper is actually dependent on what the different types of enemies. Like, the big slime in level 1 can only drop about like 0 to 5. So we create an integer, we call it health drop chance, and then again, we give it a random integer from 0 to 5, and that's essentially how many of those little health balls it'll drop on the ground, I guess. And we kind of like randomize it, so sometimes the player can get nothing, sometimes they could get 1, sometimes they could get 2, blah blah blah, all the way to 5 if it was an enemy, if it was one of those big slimes, which is enemy 1. So it checks if the health drop chance is greater than 0. If it is, then we have a for loop, and as long as I is equal to or less than health drop chance, instantiate and drop those health collectibles for the player to collect. And how the health collectibles work is pretty simple. There's just a collider, a capsule collider, a rigid body, because we give it a bounce material, so once the enemy dies and it instantiates, like it spawns all these things there, it kind of has like a since it has a rigid body, it has gravity applied to it, so it's going downwards, and then we applied a bounce material to it, so it has a little bounce when it falls. So there's that, and then there's delete collectibles, which is just a coroutine script. So after like 30 seconds, it'll delete the collectibles if the player decides not to pick it up. That's just good practice for saving on memory, I guess, even though it's a 2D game. It's always good practice to delete your stuff if you're not using it. And then, so it's just it uses a capsule collider, and then in the character script, under collision detection, we just check if it's a health collectible, which has a tag called health collectible, and if it is, then add. Each one of those balls gives health power-ups give or collectibles give the player 5 an additional 5 health. So yeah, so that's that. And then again, it's dependent on the enemy as well. So enemy 3 and 4, which is the spider and the panther in this level, they can drop anywhere between 0 to 10, and it'll create all those with the instantiate here. And then same for the flying projectile, it could drop anywhere between 0 to 10. It all depends on the enemy. And that should be it, I believe so. Yep, I believe that should make that update. Thank you guys for watching. I'll hopefully catch you guys in a new update. And we can finally see how people feel about Crescent, I guess. Alright, see you later.